To prove that a polygon in a coordinate plane is a rhombus, first you need to show that the polygon is a parallelogram and all sides are congruent. To start with, you need to draw the figure in a coordinate plane. For example, is the polygon A 1, 1, B 4, negative 1, C 1, negative 3, and D negative 2, minus 1 a rhombus. Prove or disprove. If you plot all the points to draw the figure, you should have a figure similar to this. So the polygon is A, B, C, D. To prove that the polygon is a parallelogram, we need to show that the opposite sides are parallel using the slope formula. So we find the slope of each side. The formula for the slope is m equals rise divided by run. Let us start with segment AB. So for the slope of line segment AB, we draw a line segment that is vertical from point A, 1, 2 units down, so that is negative 2 for the rise, and then 1, 2, 3 units right for the run, so that is positive 3. So the slope of line segment AB is negative 2 divided by 3, which is negative 2/3. Next, we need the slope of side CD. From point D, we go 1, 2 units down, so that is negative 2. Then 1, 2, 3 units right to C, so that is positive 3. So negative 2 divided by 3 is negative 2/3. As you can see, the length of line segment AB is equal to negative 2/3, and that is equal to the length of line segment CD. Next, for the slope of line segment BC. From point B, we move 1, 2 units down, so that is negative 2. And then to point C, 1, 2, 3 units left, so that is also negative 3. Negative. So negative 2 divided by negative 3 is 2/3. For our point, our line segment AD, from point A, we move 1, 2 units down, so negative 2, and then 1, to 3 units left to point D, so that is also negative 3. So negative 2 divided by negative 3 is 2/3. As you can see, the length of line segment BC is equal to the length of line segment AD, which is 2/3. As I said, we use the slope formula to determine the slope. Since the slope of AB is equal to the slope of CD, therefore AB is parallel to CD. Since the slope of side BC is equal to the slope of side DA or AD, therefore BC is parallel to AD. And this is by the definition of parallel lines. Therefore, our quadrilateral ABCD is a parallelogram by the definition of parallelogram. So we already proved that the polygon must be a parallelogram. Next, we use the distance formula to determine the length of each side. Now for that distance formula, we can simply use the shorthand notation from the Pythagorean theorem, which is C is equal to the square root of A squared plus B squared. Now let us use this to find the length or the distance between points. So for the length of side AB, we start from point A. We draw 1, 2, 3 horizontal or 3 units to the right. So that, and then 3 units to your B, 2 units. So the distance is now the square root of 3 squared plus 2 squared. Then we use the scientific calculator to determine that distance. The square root of 3 squared plus 2 squared. That is approximately equal to 3.6. Next, for the length of side BC. From point B, we have 2 units down. To point C, we have 3 units. So that is also square root of 3 squared plus 2 squared. Still the same as 3.6. And then next, for the length of side CD. So we draw the vertical line segment from point D, 1, 2 units down, and then 1, 2, 3 units to the right. So the length of line segment CD is 3 squared plus 2 squared also, and that is 3.6. Next, for the length of side AD. So we draw that vertical line from point D, 2 units, horizontal towards your A, 3 units. Again, we have a square root of 3 squared plus 2 squared, which is 3.6. So the length of side AB is equal to the length of side BC, which is also equal to the length of line segment CD, and also equal to the length of line segment AD, which is 3.6. So here we used the distance formula. Now, since the length of 4 sides are equal, then the 4 sides are congruent. That is, AB is congruent to BC, each is congruent to CD, and each is congruent to AD. That is by the definition of congruent line segments. So now we have already proven that all sides are congruent. So the two conditions are now satisfied. Therefore, ABCD is a rhombus by the definition of rhombus.